عين أسمر من الجامعة الأمريكية ببيروت. نشكرهم شكر خاص لأنه they have a very tight schedule، ومع ذلك سمحوا لأنفسهم إنه يجوا لعنا ويشاركونا كلياتنا بالعلم تبعهم. عن جد they have a very tight schedule. يعني أنا المفروض أبلش المحاضرة رح نقولها للآخر لأنه مضطرين هم ياخذوا محاضراتهم ويروحوا على المطار. شكرا كثير لوجودكم معنا والله. الله يخليك. خليني احكي لكم مقدمه بس احنا ليش موجودين. الاكتيفيتي هاي هي جزء من مشروع اسمه International Augmented Med. المشروع انطلق بال 2012 مدينة الجيرو بإيطاليا، عبارة عن 7 دول. من ال7 دول في 12 بارتنر. احنا جامعة العلوم والتكنولوجيا واحد منهم، إدارة الآثار العامة واحد منهم، الجامعة الأمريكية واحد منهم، في بلدية جبيل لبنان واحد منهم، وهكذا. شو الهدف من هالتجمع كله وهالبروجكت اللي هو مدعوم من الاتحاد الأوروبي؟ الهدف تعزيز السياحة في ال7 دول المشتركة. كيف نعزز السياحة؟ السياحة تعزز بطريقتين: البتر بروموشن للمواقع الأثرية والتراثية بكل الدول هاي، وانهانسنج الاكسبيرينس للفيزيتور لما يروح على الموقع يطلع من الموقع هو الاكسبيرينس تبعته مش تراديشنال. خليني احكي مثال. كم واحد منكم حاب يزور مدينة بيبلس بلبنان؟ يعني او كم واحد منكم بيعرف مدينة بيبلس؟ ولا واحد. افرض حكيت لكم عن مدينة بيبلس ومدينة عمرها 8000 سنة وحاليا اسمها جبيل، كل الانفورميشن، كم واحد منكم رح يتولد عنده رغبة انه يزورها؟ كمان بيز على الاورال انفورميشن اللي سمعتوها، يعني بجوز الموتيفيشن ما يكونش عالي، او ريز الليفل اوف كومبلكسيتي للانفورميشن، بجوز استخدم سلايد او اي بروشور، يبدا الموتيفيشن يزيد. قديش الموتيفيشن عندكم راح يزيد إذا فجأة الآن هالغرفة اللي احنا فيها اختفت وظهر حوالينا شيء بيشبه بيبلس حالتها اللي كانت قبل آلاف السنين وبلشنا كأنه نمشي جواتها. الفكرة إنه نوصل لهون. الفكرة إنه إحنا اللي هو أعتقد أنتم مزيج من طلاب من العمارة مع التصميم البصري مع طلاب أيضا. مشان نوصل للمرحلة هاي انتم بدكم تتعلموا certain technologies، certain skills، بالاضافه للارتستيك يعني talent اللي عندكم، مشان تقدر تخلق عالم افتراضي بالطريقه هاي، بمعنى هي كلها ادوات مالتي ميديا، وتستخدم هالادوات هاي تبروموت archaeological sites وheritage sites وانريتش الاكسبيرينس للفيزيتور لما يروح على السايت. This is the goal. كل الفانز اللي عم تجينا مشان احنا نتعلم as partners وننقل العلم تبعنا للجنريشنز القادمه، مشان كنا بالاخير نعزز السياحه. طبعا تعزيز السياحه فيها دخل للدوله، فيها دخل للستيك هولدرز اللي عاملين مصالح حوالين المواقع السياحيه وهكذا. فيها مصلحه عامه للكل، بالاضافه انه انتم you are learning better skills تخلق لكم better opportunities في المستقبل. This is the goal. الآن نترك الستيج للدكتور جورج خليه يتحفنا بالمعلومات الطيبة اللي عنده.
Thank you, Dr. Rami. Thank you. أنا it's easier for me إنه أحكي بالإنجليش. Is that okay? وأكيد بحكي عربي بس في كتير technical terms و it's a lot easier to speak in English. So feel free to interrupt. We can translate as needed. Okay? Is that okay? Yes. Awesome. Let me sort of tell you what I'd like to talk about in the next half hour or so. So, as Dr. Rami started saying, the goal really is to develop technologies to allow us to build immersive worlds. So immersive worlds are virtual worlds where you usually with goggles, and you have a gamepad with you, and you really are experiencing something that doesn't exist in reality. It usually augments what is out there. So I'd like to share with you a bit our experience of building an immersive world for Jbeil. Jbeil is a historical city in Lebanon, and it has there is an old castle there and a bunch of Roman ruins. One of them is a theater that has a lot of historical significance, and most of it has been destroyed. So if you go on site, they really don't see much there. So the idea is, why don't we use it as an example of what can be done to enhance its experiencing. So the goal is to take you through the technology, what it takes to build this world. Before I talk about the course technology, let me perhaps spend a couple of minutes to show you what this is like. So I have a couple of movies. This is the first one. Each one is a very short, 1 minute, 1 minute clip or so. So right now, if you go to the site, you see something like this. We're in the middle of a Roman theater. It's a smaller version, much smaller version than the one you have in Amman. Amman is beautiful, but we visited yesterday. But you see, there are a few stairs that remain. Much of the top of it is gone. So if you go to the site, you really don't appreciate all the history and how things used to be. By the way, what you're looking at here is not a video. What you're looking at here is something we reconstructed. It's what we call a 3D model. This is a 3D model, so on top of it, we can superpose stuff, we can see it from other perspectives, we can change it, we can walk on it, we can really experience it in ways that you couldn't do with the video. So the goal is to share with you today some of the techniques we use to be able to build this environment. Both the real one, so what is there, how we reconstructed this as a 3D model, and then how we augmented it in this way. So this is the virtual part. This is how historians think the place used to be. And of course, to build an environment like this, you have to build the sky, and you have to build the sea, and you have to do the lighting. And this is how it would look at sunset, for example. Again, this is not a video. This is something we reconstructed virtually. So, and the good news is, I guess, that the punchline of this presentation is, we can all do this. We have now the software tools and the hardware tools to allow us to build these environments without a whole lot of effort. So this is something 10 years ago I couldn't have said. This is in the last 10 years, there's so much technology that has developed, both on the hardware side, which is affordable now, we can afford to have these things, and on the software side, where the tools are there, and if we sort of have an idea how the workflow goes, we can actually use these software tools to build these environments without a whole lot of effort. So that's the first piece. And I also would like to, we did this, we built this world and we tested it, and a lot of people complain that, okay, this is wonderful, but still, as somebody who is visiting this virtual augmented immersive site, we still don't know what to do, where to go. So a lot of people asked for a tour guide, a virtual tour guide who can take somebody experiencing this world through this experience. So I also want to show you a video of how this looks like, and then I'll tell you again in presentation a little bit of the technology that it takes to build not just this world by itself, but also with a guide that could narrate the experience and guide the user through the experience. So let's take a quick look at this video again. So I don't know if you can hear the audio, but so this is the cube with something floating in the air. So there is a guide.
Let me give you some information about the theater.
So when a guide...
The semicircular space we are standing in was the orchestra usually used by a chorus of a play. Please follow me.
So you see, when a guide tells you, look there, look here, follow me, let me tell you what this is about, for example, because as you may not know.
Have you noticed the stone next to me? This was an altar used prior to any performance in a religious ritual to obtain the blessing of the gods. If you look along the edge of the first row of stone seats, you can see post holes in which wooden posts could be set. Perhaps for an awning to shade the audience, or a low barrier to separate the audience from the orchestra area. Follow me to the center of the orchestra
what goes on? So you see an altar, you don't know what an altar is, unless
Take a
something
look
comes.
at the front of the stage. It is decorated with 5 niches, each of which is framed by 2 Corinthian-style columns. This use of niches is unique for a theater. They could help emphasize the religious nature of the theater. The area we are standing in was covered in a simple white mosaic with a black border. Let me show you how things used to look like.
Yeah, you want to know how things used to look like. And then a new stuff. These things, how things
Here
used
in
to
the
be.
center of the orchestra was a finely detailed mosaic representation of the Greek god Dionysios, the god of theater. The mosaic is now in the National Museum of Beirut.
So you see how sort of, again, the goal is ultimately is to encourage tourism. So if one sees this, one can see there's a lot of history here, and there are some mosaic things that are in the National Museum, so maybe I should go to the National Museum and see them. So it's all part of the package. And again, the main message here is how we build these worlds, and I hope some of you sort of take-home message here will say, yes, I have some piece of archaeology I'm interested in, I want to produce it in this fashion. I use the word produce because you see that a lot of the skills we'll need are skills that have to do with art and production and choreography and cinematography and lighting and shaping and interaction. So we need to build this whole world. It's sort of the same technology, much of this is the same technology that goes into building games, interactive games, but now it's targeted towards something else. And again, we have the tools to do this. This is not something insurmountable. How many of you here have experienced some of these tools, just so that I know how to structure a presentation? Not a whole lot. Okay, that's just try just to put up information for me, not more than anything else. So then let's start and talk about this technology a little bit. So this is the quick outline of what I'm going to go through. I'll talk a bit about the hardware and the software. So okay, here I showed you something that looks like a video, but again, I keep telling you, none of this is a video. So what is it really? What do we interact with it, and what kind of software environment and hardware environment we have? And then I'll take you through the 3 steps that are needed to build this model. One is to actually construct. This is what we showed in the first video. Construct the 3D world initially, and add to it meshes. Thank you. Meshes and textures. Add meshes and textures and normal maps. These are things that are needed for the model to appear realistic to us. Again, these are technical words, so I'd like to introduce them because if you ever use software that helps you develop these worlds, you need to know what these things are so that you can use this. Again, there's a lot of underlying interesting mathematics that computer scientists have developed over the years, but none of this is terribly important for being able to use these tools to produce these models. But nonetheless, we need to understand what these basic concepts are. What is the workflow? What are the things we need to do in order to build a compelling environment that we can then navigate? And then I want to talk about actually the most interesting piece of this work is, for better or worse, we really cannot do this alone as technical people. We really need the help of historians who keep us on the straight and narrow, if you will, who really keep us honest about how things really used to look like, or may have looked like, and what is the importance of various things. And then they tell us how things used to be. How things used to be is built on serious historical theory on what the Romans may have done, things that usually us technical people are not particularly steeped in, so we need their help. But of course, whenever you work with another discipline, there is some interaction that has to take place that is not always smooth. So I want to just point this out, so it's something you should expect, and how one can smooth this interaction a bit at the technical level and the various tools. And then at the end, I'll again spend a few minutes on the interactivity. How we can put a guide in this scene and animate the guide and take the user through this. Okay, so this is the plan for the presentation. In the end, I will not mention this. Professor Asmar here will cover it. How we can, once I show you the hardware, how we can augment our head-mounted displays, our immersive displays with tracking mechanisms to be able to experience the site differently when you are on site. But we'll get to this as we go. Okay, so again, I already said this in words. So this is the Beige Theater. This was our sort of showcase. This is what we wanted to do. Again, the technology now can be developed for just about any site that has these characteristics, but this is the one we use. And it's always good to have one example that one uses to drive the whole workflow through. So this is the hardware one needs to be able to build an environment like this. Of course, I think a high-quality digital camera will do the job. This is this immersive display. This is something that you mount on your head, and this has in it really two viewers. This has in it, if you look on the inside, there are really two screens inside this device. The two screens, of course, are meant to display the image in a stereoscopic way so that we get the impression that we're looking at a 3D world. You all understand how we perceive depth. We perceive depth because we see two images in two eyes, and the discrepancy between them is correlated with how far we are from the viewer. So this is a display. Again, it has two displays and two screens in it. Each one is an HD screen, or almost HD 720 pixels. So these are reasonably high quality displays. They're not as great as a big monitor, but the technology is improving very rapidly in this area. These devices cost a few $100s right now, and there will be many, many more coming up in the next few months. Many companies are starting to produce devices like this. They're getting better in quality, better in resolution, better in lag time, and even cheaper. So this is technology evolving, but it's already at the stage where it is really usable. This company, by the way, was started by a young 20-year-old entrepreneur who left school and decided he wants to build this little piece of hardware, and his company was sold for $2 billion. Did you hear about this? To Facebook. So Facebook bought this company and is starting to develop this technology. They think in the future, not only will we be communicating by looking at a flat screen, but we will also be looking at our friends far away in this immersive environment. So this has a lot of future for this, even beyond sort of this historical context that we're talking about today. And then when we put this display on, of course, now this all we're seeing the world through it. The real part and the augmented world and all this is inside this display, so we need to move in this world. Now, this device has in it a gyroscope that tracks the orientation. So when you're in it, and we did not bring one today here because we didn't think there would be enough time, but maybe we should have. So in this, when you put this display on, if you turn your head, you see something else. So the scene changes. The scene, you actually can experience. You can look down, you can look up, you can do all this. What one cannot do yet is move. So what we often need is to give the user a little gamepad, some controller, to be able to move in this world. So one moves, just like you would move in a game. How many of you play games? Oh, come on, you can. No, I cannot believe it. This is, of course, the Xbox gamepad, because it's so familiar to everyone. So gamepad, you can move, but what's really compelling about this world, and which really doesn't come through in this presentation, is the ability to rotate your head and sort of see things. So we'll talk about translation tracking. Professor Asma will talk about this later. At least the orientation tracking is built in the hardware. So the point of this slide really is to say this is all accessible. We all have this hardware in our labs somewhere. These are not super expensive piece of equipment. So, and what I really want to keep driving home this message that this is accessible. The hardware is, the software is also accessible. So we talk about this stereoscopy. The software is also accessible. There are a bunch of software that can be used to do various things. And I told you there are 3 steps in the process. One is to build the 3D world initially. We'll see how we do it. A couple of pieces of software here that do that. And then there are some pieces of software to take what the historians and architects give us and be able to merge their models with what we reconstruct. And then there are some pieces of software here that are needed to build this interactive guide that takes the user into process. There are a bunch of tools. Some of them really do the same thing, basically, different versions. Some are commercial, some are freely available. These are commercial, of course. and these are, many of them have different versions, a commercial version and a free version. But nonetheless, really, the big investment in any piece of software is your own time. It's not the cost of the software. This is really where you do any piece of software, you have to have a project and you have to spend many, many hours to learn its quirks and see how it really works and try things and sort of learn how to work with it. But this can be done again without huge learning curve. Learning curve is not particularly steep. Okay, so let's start. Go through this workflow. What are these pieces of software? What do they do? So the first step is to really build an initial world, build this 3D model. And there is technology today to take a bunch of images. That's why this digital camera was there in this previous picture. Take digital pictures, usually a lot of digital pictures of some artifact. I can take this table with a projector on it and photograph it from different angles, maybe take a couple hundred pictures of it. And then there is automatic software that can take this collection of a few hundred images and will process it and will produce a 3D model of it. I will not say a whole lot about this. If I have time in the end, maybe I will, but Professor Esmer will talk about this, about the technology, what goes in this engine that takes these images and produces a 3D model. So you all know what an image is, because you all take images every day. 3D models, you may not know, what does this mean inside? What a 3D model really is ultimately a triangular mesh. So any object that is displayed in a computer and rendered and textured, and you can see in stereo, is really at the bottom of it, at the bottom of the presentation, is a triangular mesh. So the goal is to take, the goal of this process of reconstructing an object is to take this collection of, few dozen or few hundred, whatever, images of something, anything, and then produce a model. And then, of course, this triangular mesh is terribly ugly to look at. Here it's very coarse. Here, even if we make it more refined, this doesn't look like a real rabbit because it doesn't have colors and textures and shading and all that stuff. So we need now to go through a process to improve the realism of this object. So we need to add these embellishments, if you will, to make it look. The challenge for us as developers is to build an economical representation. We cannot afford to build 3D models that have millions and millions of triangles because they will be too slow to render. When we put this visor on to look at them, if the model is extremely detailed, then it will be too slow to render. And if we cannot render things fast enough means about 30 times a second, then we will not feel the motion as a smooth motion. So the model has to be coarse. Unfortunately, when the model is too coarse, we completely lose its realism. I mean, most of you would agree this might be an acceptable rabbit, but this probably is not. Unfortunately, this is far too detailed to be rendered in real time, and we may need to actually live with this representation. So this is not good enough, therefore we have to make it realistic. How do we make it realistic? By adding textures and normal maps and these additional things. So that's the role of this process. Okay, does that make a bit of sense of what we do? So first step is to take a bunch of pictures and produce a 3D model, then take this 3D model, this triangular mesh, and put on it the textures. So what are textures? I have some stuff here. So the 3D reconstruction, again, we take pictures, we produce point clouds. Again, Professor Esmer will talk about how this is done and some of the tools that are available for doing this. Again, we're going to create the mesh and then we're going to start to do things to it. So this is actually, what you're looking at here is the altar. If you remember, this is Beirut Theater, there's an altar there, and we'll use this to make the point. This is actually a set of points. There are probably more than 10 million points here in this image. These are taken from the set of pictures that were used on the altar. So the altar, we went to the Jbeil site, we took a collection of pictures of the altar and put them through the software, and the software produced this dense set of points. Unfortunately, with 10 million points, we cannot do anything. When I say we cannot do anything, that means we are not ready to put this in an immersive world because it is far too expensive to be able to display in real time. And there's only the altar. Remember, there's a whole world, there's a whole theater. So we really need to decimate this, Decimated means produce a much, much smaller mesh in it that we can then texture and make it look. So, and I'm going to go through the process of texturing and adding normal maps, and I'll show you the end result. And the end result is going to visually look to you, I hope, it will visually look to you almost like this picture, except that that final result will only have 500 triangles, while this has 10 million ones. So there is a whole process of decimating this, adding textures and normal maps, and make it look as good as the very fully detailed, but super expensive to render object. So this is the 10 million plus points that you cannot do anything with. One can decimate it. Decimate it means take all the little fine small triangles and combine them together into bigger triangles and do this to get some very coarse mesh. This is very small, therefore it fits in the hardware of the machine and it can be rendered very quickly, but of course there's nothing in it, so we need to augment it with some visually appealing things. And the visually appealing things are things called textures and normal maps. Let me say a few words about what these are. So typically a 3D object is something like this. This is really a 3D mesh with a color on it. So it's very plain. The color is very plain. So what we need to do to give it realism is to paste on it a high quality, high resolution image. So we can take a very high resolution image, we call this a texture, and this is pasted on this very coarse three-dimensional geometric model. So this triangular mesh that is in here, it's not shown here, but there is a very coarse 3D mesh here. So we can paste this texture on it, and then what you see when you put this display on or you look on your computer is this textured object with a very high level of frequency. Right? You see this trick? This is a trick that was invented many years ago in computer graphics to be able to use a very coarse mesh and make it look as if it's of much, much higher quality than this is of course very easy to do when the object is flat. When the object isn't flat, we have to do something else. What we have to do in particular is flatten the object. This process is called unwrapping. The word may come up. So this is a geometric model where some texture has already pasted on it, and you wonder how is this flat picture? How was it pasted on the model? Well, the way it was pasted on the model is by taking the model and unwrapping it, flattening it in some sense. That's not a very easy operation to do, by the way, but there is software that helps us do it, even though we have to actually nudge the software a bit and help it with it. The tools that are there are, they're good enough to work with, but they're not perfect, and sometimes we have to help them because there is not a unique way of unwrapping and flattening. So the way this was generated is by taking the 3D mesh, the underlying 3D mesh that's very coarse, unwrapping it. So, cutting it somewhere and flattening it, and then putting the image on it, and then sort of wrapping it back, and this is how this image looks. So this is the process known as unwrapping the model, producing texture coordinates. The word texture coordinates, this is the process of flattening a model so that we can put an image on it, a high resolution image on it. This is perfect. Anytime you have to so this is a very coarse triangular mesh. This doesn't look great. I mean, if you put this in an environment, it's kind of plain and boring. One can paste a texture on it, again, by flattening this and putting real photograph. This is a real photo of some stripe and some wood panel, and it was, one can paste them directly on, and then one gets something that is quite realistic. You see lots of examples, something boring, just plain colors. All of a sudden, one can paste some textures and see a lot of interesting detail that wouldn't be visible from this image, etc. So this is the process. So in the case of the altar, we decimated the altar. This is this very coarse triangular mesh. It's very boring, very plain. We then used software to texture it. So I want to take you through all the software. One of the pieces of software, of course, we have to use is Photoshop. Photoshop is the Cadillac of all image processing software. So this is to clean up the images a little bit and be able to see the texture and develop the texture maps and put them. So after textures, we want to do something else. Even when you put textures on, the model still isn't quite that realistic. So I want to do something else, and the additional trick that computer graphics people have developed over the years is this trick called normal maps. Normal maps is this idea of, so this is, again I apologize for quality a little bit, but I think the point may be well taken is, so here's some original mesh, very detailed. If you look on the screen actually, you see a very fine, beautiful looking model. Unfortunately, this is 4 million triangles. I mean, one cannot just put this in an environment because we have hundreds of objects like this, and just these meshes are far too large to deal with. So the idea is, why don't we simplify the mesh, decimate it, make it much coarser. Again, it's easy to do because one can take, again, the software that does this, we don't do this manually anymore. These are all lots of little triangles that combine together into bigger ones, and then those triangles are again recursively built into coarser ones, etc., until we get a very coarse mesh. This is a mesh that has only 500 triangles. Well, this doesn't look anything like a face anymore. It's so coarse. However, what is amazing is we put a texture on it. Texture is the image of that, and then one gets back something that visually, by visually looking at it, it looks a lot like the original one. So how is this done? So texture by itself will not do it. One needs to do something else. And what makes this difficult, of course, is the fact that the normal is the line that is perpendicular to the surface locally, is changing. So here there is a normal, the direction that is perpendicular to the surface goes out of the board, here it goes down to the floor, etc., etc. So how can we capture that change in the geometry, the change in the normal direction, and then the change in the perpendicular direction in such a coarse mesh? So this is a beautiful idea called the normal map. It was a big deal in computer graphics about 20 years ago. It was became the main tool. And a lot of the movies that are computer generated now use this idea of normal mapping. So this is it's also called bump mapping sometimes. So here's the idea. This idea is based on how our eye perceives light. So when we look at an image, really what we're seeing is the following. So there is some light source. If there is no light source anywhere, we don't see anything. All we see is dark. The only way we see anything is through a light source. So there's a light source, and this is, let's say, the object we're looking at. The way we see the object and the way we perceive its orientation is by how light is reflected from it. Of course, some of the light is going to be absorbed here, but some of it will go back, and the way the light is reflected to our eye is how we perceive the local orientation of the object. So the idea of normal mapping is the following, is to change the orientation of the normal at these points. So at these points, instead of having the normal, which we usually compute by taking a triangle and seeing what is the perpendicular direction to it, by changing that direction. So instead of using the real geometric normals, we use different normals that will produce a higher quality image. I'll tell you in a minute how we produce these normal maps. Again, this is an automated process. So locally, we will change the direction of the normal. So the normal at this point, instead of being in this direction as it should be, if this is the real geometry, we will say that the normal at this point is in this direction. The normal at the point next to it is in a different orientation. The normal at the point here is in the exact correct orientation, etc., etc. So these are the orientations at a bunch of points that are close to each other that normally really should have the same direction. The reason this makes a difference is now when we light this object, remember the lighting is what is done in the computer. The way this is done now, we perceive an object like this. Why do we perceive an object like this? Because the normal at this point here is consistent with an object whose orientation would have a normal in that direction. So we perceive something like this. This is very fine detail, without having to pay the cost of having a very fine mesh that captures this local geometry. So there's a trick, again, we do to improve the realism given a coarse representation of the model, which is something we're constrained to work. Again, I'm saying these things because this is the background one needs to know to be able to use these software tools. You open all these software tools to do texturing and bump mapping and light painting and all that stuff, and you see all these words and all these little add-ons, and unless you know sort of what role they play, this will seem quite overwhelming. A lot of interesting research was done to develop these techniques, all these clever tricks, and to make sure they work well. But again, none of this is something we really have to reinvent. We can use these tools, but we have to understand sort of what they do and where they fit in the whole. And the way, so these normal maps then can be applied, and the way to generate these normal maps is through a process called ray tracing. So we take a very detailed geometry, very highly detailed geometry, ray trace it, so compute all the the paths of the rays from the light sources to the eye, and then use the resulting picture to define the normal maps. And then those are applied. So when we do all this, this is what we got. Remember that picture that had 10 million points? I told you we're going to look at it again. This is it again with 500 faces. Okay, so let me go back to that 10 million plus points. So this is how it was. Wow, many slides ago. So this was it. This is 10 million points. Again, quite detailed, quite nice, really, but completely unworkable in a real environment. This is what, after we went through this process of adding textures and adding normal maps, this is the same model with few hundred faces, but I would argue just as good for visual realism. But the big difference is now this is something that can be put in this immersive world, and we can work with it, and we can look at it from any direction, and we can light it, and we can talk about it, and we can modify it, and we can do all sorts of things. Okay? So, this is the first part of the talk, this reconstruction. Again, Professor Asmar will talk about this in more detail later on in the afternoon. Now let me say a couple of words about working with historians. Historians are lovely people, but they have a different culture than me. Any discipline has its own culture and ways of doing things. So we really, we need their help, and we need to be able to work with them. So let me, again, I'll skip this, but it's very difficult to do things without having a historian. The result will not be credible. I mean, we can do all the technology we want, but really it will not be credible unless there is something behind the scenes that works. So what the historians give us usually are things like this. Geometric models, they have their tools. Some of you here understand are architects, so you probably have used AutoCAD or Rhino or whatever, some 3D model. So we get something like this, a pretty coarse geometry, a model that does not really fit what currently exists. If you remember the Jveil had only a few steps left, but there is a whole lot that used to be there. What historians do is they build how things used to be. Not how they are today, but how things used to be. So we really have to take their model, cut from it the part that sort of still exists, and then merge the current world with this cut world. And you see what the task is? So there is some little piece left of a ruin. The historian gives us how the whole thing used to be. So I want to cut from that's part that already is, and then merge these in a seamless way. Interestingly enough, the historians don't want the merger to happen seamlessly. They really would like the user who's experiencing this to see the contrast between what used to be and what is the stuff that has been augmented. Which I think makes sense, but this is sort of what we do. And there are tools to do this. Again, if I have time, I'll say a bit more about them later on, but these are mostly geometric modeling tools that involve cutting pieces out. So if you know how to do Boolean operations in a geometric modeling system, these are Boolean operations where one can union and intersect geometric objects, and then massage them a bit to fit. So there is a bit of work to be done to take the reconstruction of the current world, which is, again, has been decimated and has textures and bump maps, and then augment it with what the historians give us. Of course, you look at it, you say, well, I'm not going to use this, of course. I still am going to texture this to make it look somewhat realistic. And of course, one will texture that and will work with it. So once we have this model and we've added to it what the historians give us, let me see if I have a slide. Yeah, so we cut and remove the parts of the model already found in reconstruction. We need to rescale. Things are not always aligned, so we have to change their orientation. So there's a bit of geometry that has to be done. We really would have loved if the historians gave us a model that could just fit to our reconstruction. It would have been lovely, but think so. It's not going to work that way. We'll get a model that has a misfit, and we have to correct for that. And this is often, although actually it takes a few iterations to get this to work. Don't expect the first iteration with the historian to work. It will not. You'll be disappointed if that's the expectation. The expectation is, well, you'll ask them sort of what you'd like to get something, you work with it, doesn't quite work, and they do another iteration. And it's like you're learning how to dance with someone. You know, it takes a little while to sort of not to step on each other's toes and how to work with it. Okay, so once we have that, you know, to really give this to the user a sense of immersion, it's not just the object that we care about, but we care about everything that's around it, which is the sky and the sea, and the sea cannot be static. You know, the sea, if you look at the sea and you see it completely flat, that's not compelling. It has to move, right? There are some surface waves that have to change somehow. The lighting has to change. So we need to add all of these to the environment. And the question, of course, how do we do all of this? Because this is a big part of building these environments. And here's the good news is there are some wonderful tools these days. There are a couple of them. Unity is one. This is the one we've used mostly. We've actually occasionally used this other engine in the past called Unreal. So both the Unreal engine and the Unity 3D game engine, these are tools that basically do the same thing. They're developed by different groups. And these are used by people mostly to build games. Games you play on your Xbox or whatever, or on your phone or on your computer screen. But we are using them to complete building this environment and adding interactivity to it. The Unity is the one we've sort of ended up using more often than not in this project, partly because it is so flexible. It allows us to publish our end result, this interactive environment, which we can call the game in some sense because it's a product of this, in sort of most commonly used environments that people have access to. Unity is something you can download. The learning curve here is a bit steeper than the other tools you use. You have to spend probably a couple of days to just get the initial project going. The good news is there are a beautiful set of resources available to go through this, and lots of wonderful add-ons to help us work with Unity. So it's something if you ever want to do, you have to sort of count on a couple of days initially of some sweat and a bit of frustration perhaps, but it will work. There are lots of great examples and tutorials and tools that you can use, and it's worth it. It's so fun to produce your first world. We're going to do at AUB actually in a couple of months a little workshop where people will actually use Unity to build their first world. And we expect that in a few hours, by guiding people, they should be able to go from zero, from not knowing what Unity is, to be able to build the first immersive world with a sky and a sea. So we're going to do this. So the point of this is to tell you that this is not something that is immensely difficult. In fact, that's the whole point of this whole presentation. So we can add a person. You need to build an immersive world, so there has to be a person walking around to perceive things. You know, there are lots of these little modules, so you can add a person and move around. I put the screenshot on purpose to show you that, I mean, everything you add in this environment is going to have lots of options and lots of twiddles, and you have to fiddle with it a little bit to make it really work. You say, I want to add water, and you add water, and you get a water object, and then you decide what is the frequency, how you want the frequency of the waves to look like. You want lots of short waves that move fast, or long waves that are moving slower, and you adjust on the parameters, and you play with them a little bit, and you get an object. That is called a sea. You want to add a sky. Well, the sky, one way to look at it is we all live in a big box. It has 6 faces, and the 6 faces have images on the sky around, and this is far away, and you color them in the way you want, and then you get a sky box, and that is the impression of the sky. You want to add some terrain, so lots of things one can choose, put them on, put them with the sky and the water, and you get an image like this. So these things are not difficult to do. These are really quite powerful technologies. I really encourage you to sort of take a little time to invest and then see them in action. You can download this on any machine you have and you use it. And once you have this environment, of course, you can say publish it, not to your laptop or to your phone, but publish it to the Oculus so that we can see it in an immersive environment. The Oculus, of course, is a stereo device. It renders things for the left eye and the right eye separately. So you see here 2 images, and of course, when these 2 images are displayed to you, the discrepancy between them is an indication of depth, and you perceive this 3D world that is around us. Okay, so this is good. We have a world. It's realistic. It had what we reconstructed. Remember, we started by taking pictures of something. Took pictures, added textures and bump maps, talked to the historian, gave us a model, we added it, we put it in this world, we added the sky and the sea, and now we have this complete world, and we can start with binoculars and we can move in it. Well, not only want to move in it, we want to start doing things. We want to, for example, tell the user where it needs to go, where she needs to see, what orientation we would like her to look at, where we want her to go, etc., etc. We need to have a guide to take the user through this experience. So how do we do this? Well, user interaction is a bit more, I don't want to use the word difficult here, but a bit more involved perhaps than doing everything else I've talked about. Everything else I've talked about so far really you can do without a whole lot of hand-holding. In fact, by firing up this tool, experimenting with it, reading some tutorials, seeing some examples and all that. And then you can do it yourself. You can go have a friend of yours take a picture of you, you put it in this environment, and then you will be going up and down. And once we want to interact, we have to do a bit more. We have to program. We have to write scripts. How many of you here program in any language? May I ask? Okay, not too many. Okay, so this will require programming. So if you don't know how to write a script, it'll be a bit harder to put a guide and have the guide take the user through the experience. It is doable, but again, some experience learning scripts, writing scripts is important. But let me, for those of you who know how to program, perhaps I'll take you again quickly through some of the things we can do. So one can put a heads-up display. So one can put sort of a transparent bulletin board as the user. If you play games, of course, you see these things pop up. You hit the target, and then you see the screen what your score is and how many you missed or whatever. Again, these are things, if you know how to write a little script, these are prefabricated objects in Unity. You can instantiate them and say what text appears on them, and then you go. You cannot, and the reason they have to be programmed is they are dynamic. You're not placing them in one place and then let's go. It's this dynamic behavior in them that has to be scripted. But if you know how to write scripts, then these are interesting and relatively easy things to do. Another thing that is terribly important to do is lighting. Really, lighting is what controls the biggest, perhaps, variable in experiencing a scene comes through lighting, particularly when the environment we're rendering is something outdoors, as we're doing here in Spain. So we need to figure out where to put the sun, where to put additional lights, and how this whole shading works. So we need to think a little bit about lighting and shading in a sort of a serious way. But particularly if the sun is going to make a change. You may have seen in the video, we had the sun that was setting, and the sun setting, everything gets darker and dimmer, and then the moon will show up. All these things, again, have to be scripted a little bit. So lighting and shading is important because if we just have colors and textures as we have in this geometric model, that's not enough. The appearance really comes from the light. The day and night cycle, that's what so if we want to animate the sun, we need to have a path for it, and then the path is going to be timed, and then every few seconds or so, the sun changes location, and then we perceive something different. So this is, for example, this is Veil Theater at night, right? And this is the Mediterranean Sea, and the sun is setting to the west here. And you see, again, this is scriptable by simply changing the location of one light, the light being the sun. The sun is a point light source that is going to change its location. Again, these are all scriptable, writable loop to be able to track where things are and then let it go. And one can produce these animated effects I showed you. The guide is something, again, if we have time for a little more detailed presentation and I have the slides, we can talk about how these things can be done and what kind of scripts you may have to write. So then, again, the user is often lulled. Even when the scene is ready and we have the lighting, still the user doesn't know what to do. Well, what are we going to do to help them? We need to create a guide. The guide you saw here in the video earlier was a cube, because we're still developing this. That's why this is all in action. In a couple of months, we'll have some more interesting character. We haven't exactly decided what the character is going to look like. We're experimenting with various things. But the cues we take really are from movie making. I mean, the skill of having a guide and animating the guide to move and to take the user is the same skill that cinematographers and choreographers use. It's really about choreography. Where should the guide stand? Where should the guide go? Where should the guide take the user to? So this is the kind of stuff one has to do. And again, these are the same techniques that choreographers and cinematographers use. And in fact, they use these tools. It's not like they use any tools that we don't have access to. So to create a character, we really have to do the same process we did earlier, which is to have some 3D model of the character. We have to decide what shape it should look like. It's not going to be a boring cube. I mean, maybe a boring cube, but it may be something else. It may be something that's humanoid, something that looks like a person. Maybe a face, maybe a sphere, maybe a blob, maybe whatever, depending on the complexity one can afford to have. So we need to have some geometric model of the guide. Again, it has to be very coarse so that it is interactive and compelling and can work at 30 frames a second. And then, of course, we have to texture it to have a character. But then, in addition, we have to make it to animate. So the words you will use if you ever try to do something like this are activities like rigging and skinning and animating the character. So rigging a character really is the process of, well, let me actually start from, one can play the skeleton. If you want to use something that looks like a human, something that is a human wide, it has joints like a human, we have to create a skeleton and put joints. Again, none of this is something you have to do from scratch. A lot of great people have worked on this, a lot of cinematographers have worked on this. And they've built actually modules that one can add to Unity. Most of them are easily downloadable. You click on, and inside the Unity environment you will find them. And you download little modules. These little modules help us develop these characters. For example, we want a module that can help us rig. Rigging is the process of connecting the outer model, the boundary of a model, to these joint mechanisms. And lots of tools are there. Again, they require a little bit of programming, a little bit of script writing, nothing too complicated, but one needs to be able to program to be able to do it. And now we have a character that has been rigged. When it has been rigged, that means if we change a joint, if we change some number here, which is, let's say, the angle between, I don't know, these two joints, then it is the geometric model, the outside of the body of this character that will change. So one number will change. So once we've rigged the character, we want to animate it also. How do we animate? Well, the way we animate is, suppose we want to start from a rigged character like this and end with a rigged character like that. Right? The arm was in this position at the first stop, and then it is in this position at the end. All we have to do is start with the first position, first pose, and the final pose, and then we can hit a button and will, in the software, again, Unity does this, it will interpolate between these two poses. So these are known as keyframes, and the software will interpolate between these keyframes. So our job as designers of this world is to decide on some key poses for the guide, and then interpolation will be done automatically. And this is known as keyframe animation. It's one of the simplest animation techniques and really one of the more effective ones. A lot of computer-generated movies today use keyframe animation, nothing more than that. So for example, if you want to go from here to here in the sequence, one doesn't need all the intermediate poses. You may want one intermediate pose, if things don't look right, and then you click a button and then there will be automatic interpolation. All the blue stuff is automatically done. Right? So, I mean, this is sort of an extension of how cartoonists work. Right? You know, animated cartoons, you draw lots of pictures, right, in 2D and you move them like that. It's sort of a 3D version. All right, so the guided tour. A guided tour is also requires some user interface skills. How do you want to really interact with the user? You cannot overwhelm the user too much. The user has to be guided, and one has to wait on the user to take certain actions. You cannot really press the user. I mean, it is meant to be a pleasant environment. Right? So you're putting this on, you cannot have a guy say, go there, go there, go there, and then you can't go there, you know, the guy that moves someone else. You know, so there has to be some easy user interface elements. Unfortunately, these are actually pretty time consuming because they require a lot of testing with real users. The real users have to test the environment and then do things with it. So these are, in a way, these are the fun things, and these are the value-added things you would do when you develop your own. You don't want the whole process to be automated. You want to have your own touch to it. So there's a lot of room sort of for personal adaptation of these things. So a guide may walk along a predefined path. There are several stops usually included. Probably the guide should wait somewhere on one of these stops until the user comes to the guide, and then the guide could start talking, and then will point to certain things. We have some features here I didn't show you in the video because they're just coming online right now. Is when the user is talking about something, probably everything else in the scene should be dimmed, and only that thing should be highlighted. And this is simply a matter of adding light to point it to that location. So these are the kinds of things one has to do. A few more things about navigation. So you notice this world actually is not just a simple flat world, right? There are stairs there, and one can go up the stairs, one can go down the stairs. What you want to make sure is the user doesn't bump into things, and the worst thing one can do is have the user fall on the stairs. The falling on the stairs virtually, even though your feet are on the ground, if as you're navigating in this world, the image appears as if someone is falling, you feel your heart is going down. You feel you are falling down. This is terribly important in these dangerous environments. We allow the user to go up the stairs. These videos I showed you earlier, they are the user. That's what the user was seeing going up. So we have to take this world and make it navigable, sort of safe to navigate. We're not going to let the user fall down. We're going to have obstacles so that the user cannot go beyond something. Right? If I'm in this virtual world, let's say the world doesn't exist here, but it's all created virtually. If there is a stable here, I don't want to be able to walk through it, right? I don't want to be able to stop it. It just doesn't let me move, and I certainly don't want to fall. So how do we do this? So we have the Unity again has a navigation system that we can use for this. We used it mostly for obstacle avoidance, going up the stairs, preventing falls, etc., etc. Here's our solution, which actually worked out really well. To be able to do all these geometric operations, because these have to be done fast, these geometric operations. All these geometric operations for obstacle detection and obstacle avoidance and the dynamic behavior, all these are done on a very coarse mesh of the model. A low poly is sort of jargon for a low polygon count. This is a mesh with a small number of triangles, a low number of polygons, called low poly in the jargon of gaming. So a low poly version of the whole model is created, and this low polygon measure is not something that the user ever sees. You don't see this. This is something that's completely hidden, but it is there. It's very coarse, so it's not too expensive to work with, and it's doing a lot of geometric operations, including obstacle avoidance and preventing the user from falling. So what really exists actually in the theater is not just, this is a detailed mesh that was textured and documented and all that stuff. It's not only that. In the model, there is something else you don't see, which is a much coarser version of it. And this is what the user uses to walk on the stairs. And this is how we do all the obstacle avoidance on a coarser mesh. So navigating in this world, so there is a hidden mesh there that is there only for the purpose of geometric navigation, obstacle avoidance, collision detection, things like this. Once we have that, then the user can walk in this world with this gamepad. They can go up the stairs and down the stairs and prevent all sorts of things, and the guy with the help of a guide. And we have this world. So this is a pipeline I took you through with just some modest investments in hardware and some less modest, perhaps, investment of your own time in learning some software. You can have the skills you need to build an environment. Go take some pictures of some object and build a 3D model of it. Texture it, add some normal maps to it, add some lights to it, make it look realistic. Talk to a historian to augment it, to make it, to give it an appeal that it's added value. And then incorporate some interactivity. put it in a complete world with sea and sky and obstacle avoidance and guided and lights that change and move around. And then you get with an Oculus and look at this beautiful world. It is really quite compelling. So the message is this: is we have this new generation of hardware and software tools that are now available for us. Again, we couldn't have done this 10 years ago. It's all very, very new. These are quite compelling, and they can help us build these environments in a very cost-effective way. With modest investments of time and resources, we can build these worlds. Again, even though we're using them for enriching archaeological and historical information, historical artifacts in this project, I think you can imagine, I hope some of you, are thinking of other applications, and of course, the whole world of gaming, the whole world of social networking, Facebook buying this technology is opening up. There are many billionaires waiting to be minted by taking this technology and using it in very compelling applications. But this application of enriching the historical heritage we have is beautiful, particularly for our region of the world. It's terribly important, but this has uses way beyond this. Okay, so this was sort of a brief overview. Again, some of these things I really ran through very quickly. I suggest, we can take some questions and maybe take a 5-minute break and continue. I don't know what to do.
Yeah, if somebody has a question, please, and then we'll take a break. Do you have any questions?
Come on.
Yes. What's the difference between those software that you were talking about and engineering software, like 3D Max and some design software?
Yeah, good question. So, 3D Max is one of the pieces in the software pipeline. Let me go to sort of some of the software things we listed here. Let's see what I have. So, the 3D Studio Max is, of course, one of the tools. Did I not put it here yet? So, this is one of the tools we use. Of course, this is needed. Architects often give us 3D Studio Max or Rhino, and I put Rhino here, but or Rhino, or whatever, some 3D model. That's what typically architects deal with. So these are the tools we really needed to use to be able to merge the reconstructed world with what we get from an architect. So what we need from these tools, these sort of more engineering and architecture type of tools, are geometric operations, Boolean operations, cutting and slicing and merging and things of the sort. So this is part of the tool set we use. So this is not, there is no difference. In fact, this is one of the tools we use and we need to use.
So you have to be an engineer to use
you don't
like
need
that?
to, this is actually a good question. Yeah, I get this question all the time. Well, do I really need to know all these things? I have to be an engineer, an artist, and a choreographer, and cinematographer to do all of this? No. A little bit goes a long way. I mean, most software tools that we use right now have enormous amount of features. One doesn't need to learn all the feature set to be able to use it. One can go a long way by using basic functionality. So I wouldn't say you need to be an engineer to really use these tools. You can go a long way without. Of course, the more you use them, the more you want to use them. I don't know, how many people here have used Photoshop, for example? Yeah, so Photoshop, when you first started, it's a bit overwhelming, right? With all these menus and all this stuff. After you use it a few times, it becomes so easy. And then you start discovering more and more features and more things in it. And that's how typically one learns. And this is with almost any tool in this platform. They all sort of have this feature. The beautiful features, you can learn them sort of hierarchically. First, you learn the basic idea, you do some simple examples as well, and then you can add to the sophistication as your own time comes. But yeah, these tools are all useful. This in particular, this has enormous. This is even more complicated probably than the geometric modeling tools. But again, the simple world is not that difficult. Again, in a couple of hours, right now, you can take a picture, maybe 25 pictures of this chair, build a 3D model, put it in this environment, add a carpet, add a little lighting, and then have a user sit on it or something. So it is possible, but again.
More questions? Okay, let me remind you all that this does not end here. You can still, and you should, actually join the network that we are building. This project has a website, you can see it on the brochures. You can go there, join it, And you can keep in touch with everybody on the network. You can ask questions and you can get information. This is the whole purpose. It's not like something that's one shot and that's it. It's a continuous process. So if you are interested, please join the network and keep in touch with all the experts that are over there. And let's go to the break. Thank you all.